Welcome to the homeostasis introduction video. We're going to be examining and taking just a quick overview of how homeostasis works in the body. And as we do that, we're going to give a few examples of how homeostasis works. And then once you finish these notes, you played during class, or I'll link the video into Canvas, then you're going to complete an activity or a homework assignment where you're looking at different body systems, mentioning the organs within that body system, and then saying, how does that body system carry out homeostasis? Homeostasis, by definition, is the ability of a system, a body system, whether it's cardiovascular system or the integumentary system, which is your skin, or a living organism as a whole, so the human body as a whole, to make tiny adjustments over and over again so that it can stay at its regular state. So to define it, it's the ability of the system to adjust its internal environment to maintain a stable equilibrium. That's a lot of fancy words to say. Your body wants to stay comfortable and regular. When you get too warm, you respond. When your blood sugar gets low, you feel hungry. When you get tired, you want to rest. When your muscles have engaged in a lot of activity, they fatigue to such a point where they stop functioning and you stop. When you walk up the stairs, you breathe a little bit harder so that you can oxygenate your blood. So anytime you're outside of normal, your body has to do something to bring it closer back to normal. There are 5 main steps. You'll notice that I have a couple of blue words that, maybe it looks like there's 6. So the stimulus step is when things are happening. You start doing jumping jacks. That would be the stimulus. And so when you start doing jumping jacks, receptors in step 2 pick up on the fact that your muscles are contracting and creating body heat, that your muscles, in order to contract, need more oxygen and are producing carbon dioxide. So what delivers the oxygen and the carbon dioxide, or removes the carbon dioxide? It's the blood. And so you're going to breathe harder to oxygenate, and your heart's going to pump a little harder, faster, to deliver that blood. So the stimulus is the jumping jacks. The receptors are the blood oxygen concentration. Okay. The control center in step 3 is a lot of times is the hypothalamus in the brain, and it will take the input, the messages that are coming from the receptors, and signal and kind of compare it to the normal. Is this normal for me, or is this too much in one direction or too much in the other? Do I need a lot more oxygen? Do I need to get rid of carbon dioxide? Am I too cold? Am I too warm? Do I need, what am I, it's comparing it to that set point, that normal regular state. In step 4, the effectors are signaled. The effectors are just the body parts that are going to respond. So I'm doing jumping jacks. I'm causing the stimulus of doing the jumping jacks. My receptors have picked up on the fact that my muscles are releasing heat, my body temperature is changing, and that my muscles may be requiring more oxygen, more nutrients, and a removal of waste products. The hypothalamus gets all of those messages and says, ooh, we're a little bit off a set point. I'm a little bit too warm, and the muscles definitely need more oxygen. So my effectors are going to be the response system that will then do step 5 and actually respond. So if I'm getting too warm, my sweat glands wake up. My sweat glands know that they're going to be doing something. If my body gets too warm, my blood vessels will what we call dilate. And by dilate, they open more so that heat can be released. In that dilation, also, it allows for the blood to be more easily delivered to the muscles so that oxygen and carbon dioxide gas exchange can happen. The effectors could be my lungs and my breathing rate. My muscles are saying, hey, I think I need more oxygen and nutrients, so my lungs, I breathe faster in order to get more oxygen. My heart rate responds. So my heart and my lungs could be receptors, or my heart and my lungs could be effectors, because they are going to do something in response to being out of the regular state. And then the response is simply, what is that actual response? If we look at the actual stimulus, the stimulus can be any input that takes the body away from its normal state. In the case of body temperature, it could be exercising or being in a room that's too warm or too cold. You could also be creating a stimulus of a sugary snack or something like that. If I kind of expand upon the picture of the runner, here are a lot of stimulus. She's got solar radiation. The sun is beating down on her. It's hot outside. It's humid, so her sweat is not evaporating as easily. Metabolic heat production, that's the actual heat produced by her body because it's exercising. The ground is kicking up heat at her. Those are all stimuli that are affecting her ability to stay at her set point. We can look at the receptors. In this particular slide, we can see that this is a layer of skin. And labeled in all the blue would be some of the receptors. So there's different nerves under just under the surface of the skin that feel when you touch it, that feel if you've cut yourself or if you get punched. So there's a feeling of pain. The heat receptor picks up if the room or the circumstances are too hot. And the cold receptor is whether it's too cold. And if you really look at and kind of follow my arrow here, you'll notice that they all have arrows. And they just say right there, to the brain. And we'll see in a second what happens there. Okay, but from the brain, we'll see that there are effectors, things within the skin that are going to end up responding. You have a sweat duct, you have sweat pore where the sweat will come out, and the kind of a gland. You have hair with a muscle attached that can make your hair stand up. And so your body also has receptors and effectors within that same kind of location. Your control center and set point, in many cases, your control center is your hypothalamus. Okay, the hypothalamus is a small part of the brain, and it recognizes when those nerve messages from the receptor go to the hypothalamus. It can notice if your blood sugar levels are too high or too low, and if your amount of nutrients in your blood are too high or too low, and whether or not you're hungry. Body temperature, your arousal, your perspiration, heart rate, pupil dilation. So different factors get controlled from this hypothalamus because that center measures the stimulus and measures it against the set point to say, do we need to do anything? If you feel regular, your body is not going to do something in response. Your effector, that's step 4, the effectors are the body parts that respond, and in their response, we have a couple of different body parts that would respond as far as your body heat is concerned. And so in body temperature control, the effectors might be the sweat gland and the erector pili muscle that make the hair stand up when you have goosebumps. It could be the arterioles, or those little tiny blood vessels under your skin, and whether they constrict or they dilate to help hold on to heat or release heat. And they're showing that the effectors are nerves that are sending out to these different body parts so that a response can occur. So the arterioles are the blood vessels, the little muscles right under your skin that give you goosebumps, your sweat glands, your muscles, whether they will want to move when you're cold and you try to move a lot, or if they want to not move. You want to get real lazy so that you don't produce heat. So the effectors are kind of the nerve impulses that go to the body parts so that the body can respond. And then finally, the body will respond. And in this slide, they're talking about body temperature. If your peripheries or if your body is cold, the hypothalamus sends those nerve messages out to the capillaries to constrict and hold on to as much heat as they can. They signal to the little muscles under the skin right by the hair to make the hair stand up. And then when the hair stands up, air pockets form, and that warm air gets held by the skin and helps you stay warm. If you're cold, it'll also signal to move or constrict your muscles so that while they're contracting, they'll produce some body heat. When your organs or your peripheries, your appendages are hot, those same blood vessels will open, and then that helps for the release of body heat. You will sweat, and evaporation takes away body heat. Think about when you're exercising and you're sweating, how much that cools you off. But later, if you're all sweaty and it's cool outside, how being wet makes you really cold because it still evaporates and takes body heat away from you. But the conditions are no longer warm enough for you to need that to happen. So being wet outside in the cold makes you feel that much colder. Your brain will also signal to you behavioral responses. Not every response of homeostasis is a what we call physiological response. Not every response is a shiver or goosebumps or sweating, something that you have no control over. There's a lot of physical responses that we have. I can put on a sweater, I can take off a sweater. I can wear pants, I can wear shorts. I can make sure that I'm running with a hat so that the heat doesn't escape. I can run through a sprinkler on a really hot day so that my body is wet, and therefore it will evaporate and take heat away from it. Sometimes the response will be that I need to eat or I need to drink some water. Sometimes the response depending on the different body systems, it could be that my heart rate is racing so fast that I need to rest. I need to take away the stimulus that's causing me to, have that heightened response so that my choice is to rest to bring my heart rate and my breathing rate back down and to stabilize my blood gases and my nutrient levels. So it does say here in this picture, behavioral choices. Some of your choices will be physiological, meaning that the body just does it for you, and some of the responses will be behavioral, things that you can choose to do. The last slide is a definitive overview. It's a very general, it's mentioning 9 of what we consider our 11 body systems. We've got the nervous system, the cardiovascular system, digestive system, muscular system, endocrine system, respiratory, urinary, lymphatic, and integumentary system. In your homework, when we're done with this video, you're going to go into the Module 1 synchronous Week 2 assignment. And there's going to be a couple things linked there. I'll link this PowerPoint. But there's also going to be a table to fill out. And for each thing, you're going to say, okay, cardiovascular system. Cardiovascular system is made up of the heart, the blood vessels, and the blood. Its main functions and main methods of maintaining homeostasis are increasing or decreasing heart rate to respond to the needs of the muscles, sending Okay, so you're going to talk about the functions of that system and how it keeps the body in its normal states. This PowerPoint slide is a good, very general description. It did leave off the reproductive system and the skeletal system. You will do those on your assignment. OpenStax section 1.5 is a good thing to look through, and I will put a link from the introduction video into Canvas as well. That does a really nice job of a general overview of the different body systems and how each body system helps the whole body stay at a regular set point of homeostasis. Your integumentary system is really responsible for your body temperature. Your muscular system is responsible for your movement and some body heat. Your nervous system is really responsible for sending all the messages from the receptors back to the effectors. And so this is, again, just a very general overview of the systems that you will be investigating and, giving a very brief overview of. And so, like I said, I will be putting all the links that you need into Canvas for you to be able to complete your assignment. And that assignment will be due Monday when we meet again for class in person. Bye.